Welcome to NEK at our studio here in Oslo at Lilleaker. My name is Arild Røed. I'm the manager here in NEK for our standardization work. And I'm also secretary of our committee for offshore and ship cables, NK18A. And with me here today, I have Ivar Bull from DNV Maritime. You're a principal engineer and you're also the chair of our committee NK18A. Welcome.
Thank you.
So, Ivar Bull, as a principal specialist in DNV, what do you do normally?
Mainly I work with certification of cables. DNV has about 2,300 certificates for different kinds of cables. So that's a lot of maintenance work. They shall be renewed every 5 years. And we also have lots of initial new approvals with cable manufacturers around the world.
Okay, thank you, Ivar. We have a little agenda here today, so I will just start by going through that. So first of all, this is a webinar that we are hosting mainly to promote the new edition of the NEK TS 606. So of course we will have a little introduction of that publication. First, just a little bit of history, and I'm hoping you, Ivar, you can help us going through that. We have some slides to show you as all.
Yes.
And then we will go through the major changes of the newest, the 7th edition, that is actually. And then also after that, we would like to discuss a little bit about the committee work, the committee behind this publication, what kind of committee this is, and what kind of discussions we have there. And to help us with that, we asked one of our committee members, Hermod Iversen at AMO Cable, to make a little presentation about one of the topics that we discuss, which are cable lugs. So he could not be with us here today, but he has recorded a small presentation. So we will play that for you. It's about 7 minutes only. So we just play that and we can go back and discuss it a little bit. And at the end, we will hopefully be able to answer some of your questions. So all of you who are listening now, you have the possibility. You can type in a question and we will see it on the screen here. And depending a little bit on how many questions we get and how much time we have left at the end, we can discuss a little bit about those topics. And we will try to keep it within about 1 hour, but maybe we'll go a little bit above 1 hour or so, I don't know. Or maybe we'll finish earlier, I don't know.
Yeah, depending on questions.
Yes, exactly, yes. So, okay, Ivar, should we just start with the presentation? So I just have a very short 2 slides about the NEK first, just for new listeners. So just to explain what the NEK is, it's an independent organization. It's the Norwegian member of IEC and the Senelec. We are a not-for-profit organization, and here you can see the logos of our founding members governing our organization. So that's a very short introduction, so I think we can start by looking into the history, Ivar, about this new standard.
Yeah, well, it's not actually new because it has a history of more than 30 years. So it was the origin dates back to 1988. So there was a problem in the beginning of the oil to say, boom in Norway because every project has a specific, or it was project-specific cable specs. That meant that after one project, you could have a small mountain of cable reels remaining that was not used. And the problem was that for the next project there would be another specification because the engineers wanted to have maybe special cables for each project, which meant that there were a lot of scrap cables could not be used for the next project. So therefore, let's say Draka, Norsk Kabel, they had 40 different types. And in 1987, BP Norway, they wanted to have a solution for this, and they suggested to start the work to make a standardization for the cable types.
So was this only a problem in Norway, not in other parts of the world?
I'm not aware that there was standards. What they did in America, they had the American standards. I think they had some standard there as well.
But anyway, I think this is a little bit, you know, the curtain and the explanation of why this is still a Norwegian sort of made here in Norway, a specification, and not by, for example, IEC.
Yes, they could create some confusion because it was called a standard. So since many years ago, it was renamed to a technical specification. So it's actually something that is published by the NK 18A. So it's a Norwegian specification. But that said, it's a commonly international used. It's an industry standard in practice. So what it does, it actually uses IEC, but IEC has lots of a wide spectrum of possible choices. But NEK, they narrow the choices to make a kind of top of the shelf specification for all the different options to make a more narrow part of the IEC possibilities.
Okay, so we have another slide here. It's you mentioned other companies here. It's the same with them, with the big oil companies here, Kværner Engineering, DNK, and STK.
Yes.
They all participated that time?
Yes. So it was the big oil companies and Kværner Engineering and Draka Norsk Kabel. And the standard telefon- og kabelfabrikk, no Nexans, they participate.
Yes, that's Nexans today.
Yeah.
Yes, and you already mentioned some of this, I think. But so based on, to sum it up, it's I mean, just based on the IEC standards, you which specifies a lot of different properties.
Yeah.
So
and the benefit is that it's much easier when you have a standard that was commonly recognized. It was much easier in the tendering process. You didn't have to specify all these bits and pieces and details. You could just say according to NEK 606. And in NEK 606 there are special types. You could say it should be like P101 or in the old days it was P1 or P4 or something like that.
So could you say that all 606 cables are also IEC cables, but not necessarily the other way around?
Yes, they are. The NEK 606 types, they are based on the IEC, but in addition to IEC, IEC does not have the specification for hydrocarbon pool fire. They don't have the specification for jet fire. That is an ISO specification. Previously there was no specification for mud, outer sheet, the oil resistance. Now there are some of these things are built into the IEC standards. So it's basically IEC, but in addition there are some NEK specialities where we didn't find the IC reference.
Okay, and also here on the slide we can also see the cover page of the new edition of 606. So we got a picture here from Johan Castberg. Yes, so we have some examples of main cable types here.
Yeah, there are 4 of them. The first one up left is a fire-resistant control and instrumentation cable. And what you can see that around this tiny small cable element there is an extruded inner covering, which makes the cable semi-gas tight, and that is also useful for use in the gas dangerous areas. If you did not have this extruded inner covering around the elements, you could have more possibility or risk of gas migration along the cable. So that is part of the specification to have this extruded inner covering. Left bottom is a low voltage power cable with 3 cores. You have also the extruded inner covering. You have the armor or this common braid. Then you have a medium voltage cable. The red one is also NEK standard, high voltage. And the lower right is a fiber optic cable, also kind of standardized.
Do all of the 606 cables have this braid? As on this picture?
There are some without the braid. There's the B, let's say RFOU, the 4 letters RFOU for the type is according to a table inside NEK 606. So this O is for the copper braid. So if you have a RU cable, that means that there's no braid. So some few of them does not have the braid, like RU or BU if it's a fire-resistant cable. But I think most of them are armored type or braided types. Yeah.
Came to think about it, this was also these cables were pretty much the basis of the discussions in the hazardous locations group NK 31 when they wanted to change the requirements there to allow certain types of cables to be used with the through glands so that you can bring the braid inside of the enclosure instead of dismantle it outside of it.
Yeah.
So and then these specifications were used as at least as a basis, depending on the size of the braid and how it was molded and because I most of these cables and they are quite tight, right? I mean with regards to leakage because the braid is.
There is a gas leakage test in this IC 6079 part 14, isn't it?
Yes.
Annex there. So there's certain requirement that the gas pressure shall not drop too quickly.
Yes, because
I'm not sure we can call it gas tight, but
it's not tight.
No, semi-gas tight, but it's better than a cable that's completely just cable together without this extruded inner covering. Yeah.
Okay, we can move on a little bit. Yes, I think we have mentioned this is just about the construction of the.
Yeah, there are some specifications. But we see, it's in Norwegian, but this leder, the conductor is requirement that the conductor should be tinned copper. It's not copper. So again, here we see that NEK 606 puts on the top shelf specification. We want tinned copper to make it more corrosive, corrosion resistant. And when it comes to insulation, we specify the EPR or XLPE. Now we can also have the silicone insulation in some cases, but it does not. In the old days, we also had the PVC insulation. It was terrible with the corrosive during fire and poisonous black smoke. So that was never accepted in the NEK 606. And when it comes to this inner covering, that is what I mentioned with the extruded inner covering to make it semi-gas tight. And the outer sheet is also specified mostly with the SHF2 cross-linked outer sheet. And with the option to have it oil resistant or even mud resistant or hydraulic oil resistant for really demanding applications.
Okay, and then we have some pictures here of some of the tests that may or may not perhaps be done.
Yeah, these are again to make it kind of the top shelf. We have certain properties like flame retardant. All the NEK 606 cables should be flame retardant in bunch. That means when you bunch the cable together on a cable ladder,
like we see on the picture.
Yes, normally we the SOLAS and DNV and class rules require that you have fire stops every 14 meters on horizontal cables or every deck when it comes to vertical installation. But when you have this, when the cable has passed IEC 60332 part 322, 23, 24, etc. bunch test, you don't have it. You don't require this additional fire stops. So that again means when you have the NEK 606 cable, this is fulfilled. You can see in the left picture there, that is a single flame spread test. And in the DNV rules, we always require at least single flame retardant test. But in that case, if you only comply with the 6332 part 1 test, then you need additional fire stops. But when you comply with the part 3 bunch test, then you don't need the fire stops. So it's easier installation, easier for the yards, easier for the surveyors, everybody, because when you use the 606 cables, this is complied with.
So, but so if I just have a cable and it's not 606 and it's not a DNV class ship, perhaps, then it's not necessarily gone through this test.
Exactly.
So this is not...
then you don't know. Then you have to check every detailed specification. Does it comply with all these common, let's say, good industry practice or top-of-the-shelf requirements? So NEK 606, if you can... when we write and certificate that this complies with NEK 606 specification, we are quite clear that this complies with all the requirement. If it does not, we will write it in the certificate.
Okay. We have another...
That's another important property when it comes to halogen-free. If you have a PVC cable, it's very common in the Far East, in many markets there. If the PVC cable or a halogen containing cable burns, you will have the thick black smoke, as we can see on the next slide. It will not only be a risk for the life, for the passengers and the people on board. It will be a huge risk for all the equipment. And after a fire with halogen cables, let's say PVC cables, they were, by the way, prohibited by the 60092-360 standard back in 2014. But still, the outer sheet can be PVC. It's still allowed with ST1, ST2 outer sheet, which is not... I mean, it's good that the insulation is withdrawn, PVC insulation, but still there could be, in some cases, PVC sheeted cables. But these PVC sheeted cables will not be accepted by 606. 606 will only accept SHF2 or SHF1, halogen-free outer sheet.
But is it only chloride or is it all kinds of halogens?
Yeah, as you can see, it's very small on this. You can see the periodic system and the figure to the left there. It's second from the right is a seventh group or row in the periodic system. There you have fluoride, chlorine, bromide, iodine, etc. And all these can create a lot of harm, both to life and it will create smoke, and it's extremely corrosive because these substances are very reactive. So,
but low or halogen-free doesn't necessarily at the same time mean low smoke, does it? You can have a lot of smoke maybe, but even if it's halogen-free?
It's not one-to-one, but in many cases the materials will also comply with the low smoke test.
Right, so it's both.
But not necessarily. It's not. You cannot say it will be exactly the same, but many cases this will go hand in hand. These requirements or these properties for materials. Yes.
And the smoke also is perhaps less toxic. To breathe in.
Yeah.
If it's
less toxic. But this is also the toxicity test is not specified in the NEK 606, but that is commonly used for Navy standard, for example. That is NES, the Royal Navy or the British defense standard specify this. So in some cases we have also the toxicity standard. Maybe that could be an idea to have as an option in the NEK 606 in the 8th edition coming in some years.
Something for the future, maybe.
It's possible to have that as a possibility. It's a good property.
I'll make a note of that.
You
Ivar.
can make a note. And for diving systems, there will be a requirement for toxicity test as well.
Okay, what more have we here?
This is, of course, on open deck application. It's not important, but for passenger ships, this is not offshore, of course.
Yes.
But for along escape routes, in living quarters and those places, it can be a good idea to have low toxic smoke cables. Yeah. And in this case, you can see this is a good. I witnessed this test at Raka, and they have allowed. They say, please use it. Please spread this. Not the good news, but the bad news about this, because here you can see in the left picture that is a halogen-free cable, and in this case, I think it has burned for about 2 minutes. You can see the small flame burning into the little black burnt part of the cable, and you can see it's completely possible to see the emergency exit sign, which is, you can see the smoke chamber is about 30 centimeters deep, and there's no problem to see the exit sign. And it's possible to breathe there for a short time. You should, of course, not breathe in a long time. You should evacuate, of course. But when you compare with the PVC cable, you can see, you can hardly see the flame in there, and you can absolutely not see the emergency exit. And this is only 30 centimeters deep chamber. Imagine you are in there in a room, and you want to evacuate, or you want to go in there, you want to extinguish the fire. You don't see the flame, you don't know where to put the water spray.
And this is still allowed in, let's say, in sort of general international requirements. If you don't, you say if you use the D&D class rules, it's not allowed?
Yes, sometimes we are afraid to have too strict rules if other class bodies.
Because there is a competition there, right?
Yeah, we should not be difficult, let's say, but we should also promote the safety. So the good thing is that the ISC agreed back in 2014 we should no more have this PVC insulation. But still it's not prohibited with the PVC outer sheet. But using NEK 606 there will be no PVC outer sheet. And for passenger ships, I have checked with the big yards like Saint-Nazaire, the Maya yard and the Turku yards and these big cruise ship yards. The industry practice is mostly to use halogen-free low smoke cable, so that's good. But we don't have it explicitly in the rules, and I would like to see in the rules and that we should have the halogen-free low smoke. But in practice, it's industry practice, and it's. I think we are in the right direction there. But it could be formalized in rules and also in the standard. Yeah.
Yes, and this is just another test, fire test.
That is for important cables where we have to ensure that this cable will maybe not survive a fire for a long time, but at least work for, let's say, 1 hour, 2 hours.
Longer time at least.
It will normally it will not break down immediately. But if there are firefighting efforts and you put a fire hose and spray this with water, normal cable will just break because of the water. But in that case, there are also, as we can see, in the next slide, there we can see the additional test where you have the water spray. And these cables are tested the last 5 minutes of the 2 hour period. The cables, the burnt cables are they are exposed to a water jet, and if they pass this test, we are more let's say confident that the cables will also survive the firefighting efforts. But this is optional, this is an extra test. It's not mandatory on ships.
And then we have the hydrocarbon fire test.
Excuse me, just let me
add. Sorry.
It's mandatory for some cases of a safe return to port passenger ships.
Okay.
Then this type of cable can be used as one option. Yes. Yeah.
Then we have another test.
Yeah, this is something you will not find in the IEC standards, this hydrocarbon fire. So where you have the pool fire, the hydrocarbons burning, then we have a fire curve that goes higher than the normal cellulose fire that is used in the IEC 60331 part 1 and 2 standards. So this is a higher temperature, more demanding test. And it's burning with 10 or 12 burners in a big chamber like this. Not a single flame burning just a part of the cable like the 60331 test.
It doesn't look like there's much left.
No, it's a frightening view, yes. So this picture is after the test. So you can also see it's a kind of all these plastic parts are more or less burned away. And it's only the inorganic parts and the metal left in this case. But cable still, if it passes test, the cable is still working and transmitting power, transmitting data. And so.
Not now on this picture?
Yeah, I think it passed the test.
Okay.
This one. Yeah.
Yes, and then we have the jet fire.
Yeah, this is this is a worst case. And if you have hydrocarbons under pressure, and let's say if you have a leak in the pressurized hydrocarbon oil tube or something, then cables may be exposed for this kind of fire. It can be 1200 degrees up to maybe, if it's the extra high heat flux fire, it could be up to 1400 degrees. Really demanding, and only the very toughest protected cables will survive for maybe up to half an hour in this scenario.
Yes. I think then we have went through some of the tests.
Yes.
And this is just a summarize slide, I think.
Yeah, so what you can say, to summarize, the NEK 606, it offers a complete set of requirements for offshore environment and top shelf properties. And if you use the NEK 606 specification, there's less need for all the detailed specifications. You can just refer to the NEK 606 commonly used industry practice. So you can make the tender documents much shorter, just refer to we want the P104 cable, let's say, with the mud resistant in addition. Then you have, that's it. So it saves time, resources, and let's say everybody knows what we are talking about if you are familiar with the standard. Yeah. So today, after more than 30 years, the NEK 606 is a commonly used, not a standard, but it's a internationally well-recognized standard, much referred to in the offshore business.
And formally that's, I think, also why we call it a technical specification, because we don't we're not saying that it's an international standard in that way. It's a specification that you can use to specify these cables.
Yeah, yeah. And in our case, we have, I think we have 250 certificates referring to the NEK 606 cables. So here in this picture, you can just see example of mostly European cable manufacturers supplying this NEK 606 standards. There are also many. There are
probably
Chinese,
many more. It's just to
many more today.
Just to show that there are many manufacturers that can supply cables
lots
according
of
to
Chinese
606.
With the NEK 606 cables, and American. Yeah.
Okay, Ivar. I think we need to move on then. Now I think everybody has got a good grip on the content and the use of what this publication is.
Hopefully.
So now we can maybe just discuss a little bit about what is the newest development of this publication. So we recently published the 7th edition of this publication, and the committee, of course, has been working on this for a while and made had several discussions and figuring out what needs to be updated and not. So what we see on the screen here is just the cover page and the summarize just of the content. And these are just the headlines. And also within the first pages of the standard, there will be a list of the major changes. And this is what we see on the screen here now. So there are 6 bullet points with the main changes in the new edition. So we can just go through them briefly. So firstly, we have this change of references to the IEC 63331 standards. So we have two standards that are withdrawn. And on the bullet point 2, there is a new one that has been introduced. So what kind of standards are these, Ivar?
Yeah, just to mention to this first bullet point, these standards were published back in 1999, so they were quite old and refer to lower temperatures and without the impact you have on this newer standards. So the newer standards are a little bit updated, a little bit tougher to withstand. Yeah.
So this part 4 that we see on the screen now, so we have deleted this part 21 and 25, and you can see that number 4 is added instead of these two. And this part 4 is quite new from IEC.
Yeah.
So
for the high voltage cables.
Yes, so I think that was published in December or something, or even January, around there.
Yeah.
So I think we have been waiting for this standard actually. So once it was released, we found that we could publish 606.
Yeah, and what is important to note is that ISC 6331 Part 1 and 2 from back published in 2018. In their scope, they also refer to not only power and instrumentation cable, but they refer also to data communication cables and fiber optic cables. Even though the acceptance criteria for these cables are not mentioned. But the kind of test setup is the same. These standards 6331 and 2 can also be used for data cables and fiber optic cables.
Okay, next. So there are 2 tables that we have deleted because I guess there were no longer need for them. Yeah. Referring to the colors of the conductors. There are other tables, of course, that covers this. So these 2 are no longer needed. Yeah. And the remaining tables for low voltage and high voltage, they are here, but there are some change here as well in old. So these are, from my understanding, it's just following the international standardizations of coloring of the conductors. So this is just an adaptation, I think.
Yeah, and in many cases it's possible for the purchaser to specify other colors. It's from my point of view, it's not very strict, but I think mainly it's very common that you have the black outer sheet for the low voltage power, you have gray for the instrumentation cable, and red for the high voltage cables.
But then we have a whole new clause in 606 compared to the previous edition. And this is for cables for battery circuits and primary DC distribution grids. And this is a major change, I would say.
Yeah, this is something we have for many years now. We have been asked, what should we do with the DC distribution? Shall we use a normal 60 or 92.353 cables? Or but we had a problem there because in 60 or 92.353 for low voltage power, it mentioned it can be used for DC 1.5 the nominal voltage, but maximum 900 volts to ground. And in many these distribution systems, there are battery systems which can have a voltage of 1080 volts, 1200 volts, and so on. And then actually it was not valid to use this 353 standard. And what we did in some cases, we specified cables for 1.8/3 kV to have the extra insulation thickness. But now we have specified in the 606 a cable type where we have kind of interpolated the insulation thickness between 1.8/3 and 0.6/1 kV cable, so something in between.
So I personally also, because I'm sitting in several different groups within ship standardization groups and the offshore groups, and this is a request that and a discussion I think that comes up in several groups, also in the maritime battery group in ISC. They are requesting this, and as you already mentioned, the available cables that they have, and using this 1.5 rule that you can come up to 900 volts, but these battery systems are often above that level.
Yeah.
So they are requesting some other ratings. And of course, the question that many are not able to answer is, is it okay to go up to 1000 volts maybe or not, or what type of cables, etc.
Yeah.
And I think we have a positive response that this will be looked into in IEC as well. But I think we discussed in our group that we could be able to provide something here in 606.
Yeah.
Because the discussions in IEC will probably take some years.
Yeah, we had an IEC meeting, in Ålesund recently,
yes.
and there we also have this on the agenda to start work on this. We have started, I think it's a proposal for new work, or to include this into the 353 standard, probably.
So maybe in the 8th edition of 606, maybe we can provide a reference to some IEC work on this.
Yeah. And if it's covered in the IEC, then we can maybe delete it from NEK 606 if it's not needed any longer. But for now, we have it as a reference for the industry.
Exactly, and I don't think you can find something similar at the moment than other places. So that's why we did it.
We have the solar for solar systems. There are DC cables for, let's say, up to 1500 volts, but that's not exactly the same. And as you can recognize, if you are if you are a cable nerd, you may recognize that this table here starts at 2.5 square, and for the 1 kV cables, it will start at 1 square. That is the minimum conductor size. But for 1.8/3 cables, its minimum cross section is 10 square millimeters. So for this we have, it's not written in stone, but we think that it's reasonable to maybe start at 2.5. We could start at 4 as well, but the insulation thickness are good, and we have calculated the maximum electric field stress on the conductor, close to the conductor, and it's within a good margins, I would say, yes. So it should be completely safe to use this kind of constructions for DC. Depending the voltage there, how much you will have if you have a battery system of 1200 volts. It depends also if you have this. I'm not expert on this, but you have this unipolar, polar, or bipolar systems. I think it's depending if you have some kind of neutral in the middle and you have plus 600 or minus 600, or if you have 0 and plus 1200 and so. But we have this colleague working on this DC distribution standard in IEC and another group. They are working on this. And I think this I don't remember.
Are you thinking about Svein Blystad from Kongsberg Maritime?
They worked a lot on this, and Svein Blystad, and they have working on a standard on this. So yes. I have been in communication with him.
Yes, so they are leading a working group. It's working group 33 for those who are interested. They're working on DC distribution grids in ISC.
Yeah.
Yes. Okay, we have to move on, Ivar. There are some changes. We can go quickly through them. So there are new cards, as we call them, or cable properties. So mainly, I think we can say briefly that some of them are to have an increased voltage levels.
Yeah, for the new, let's say, readers of NEK 606, I can just, most of you probably know all this, but in the beginning of NEK 606, we have all the specifications and the scope and the tables and sort of things. And the main part, so to say, is it an appendix or something? But
it's Annex A.
It's Annex A, and then you have all the detailed specification, and for each cable type, they have a number, and they have a card, so to say. So this is an example of one of the specifications where you say, where you can see the cable from conductor and all the layers of the leak. You can see building up the cable and specify how this should be or which options you have.
Yes,
Yeah.
and now we have just added some extra types.
Yeah, this is a completely new one with a much higher voltage that we have recently.
Yes.
Normally in the DNV rules we had something that the maximum voltage on board ships or offshore should be 18/30 kV. But we see now the need for large compressors and the offshore and subsea systems. We may need much higher voltage. And of course we should not restrict the technical development. We should just be sure that everything is safe and that we specify some. So this is a new card for the much higher voltage level, and it refers to the 6092354 for the high voltage cable, and it also refers to one of the other IEC standards for.
We have class 2 and class 5, and then we have the 350. The 6092350.
Yeah, there is also a standard referring to, and not the 354 standard shipboard series, but let's say onshore high voltage cable standard.
Okay.
Yeah.
And then we have added some cards related to the DC cables that we just discussed.
Yeah.
Some various properties on that 1500 volt rating.
Yeah, and the first one is without armor, as I mentioned in the beginning of this presentation, the RU and the TI, the without the armor. And that was also discussion, do we need the armor for these cables? But we have discussed it and found that it's acceptable to have also unarmored at this voltage level. But for the standard 1.8/3 kV cables, the armor is required. We actually did a little error there because we put one of these types without the armor, and I found out in the specification, in the standard 353, it's actually required, so we had to withdraw this and correct it only to accept But now, when we have this card for the unarmored, we can again introduce the unarmored DC cables for 1.5 kV. Okay.
So this was the last slide, and we have already spent 45 minutes, Ivar.
Yeah, more than that. Yes.
So we should move on in our agenda. Moving on now to discuss talk a little bit about our committee work, what we are doing there. In addition, of course, to making 606, as we have discussed. So I just have first a couple of slides just to explain the committee work, and then, as I mentioned earlier, we can move on to one example of and the presentation from Hermod Iversen.
And as you can see here, it's a ship on the picture. So now we leave the pure offshore business and also go NK18A. It's for shipboard cables and offshore.
Yes,
it covers both of
both of them. Yes, and but now we are looking at the mother committee, NK18, that has everything on standards on ships and offshore units, installations and design and everything. And then we have NK18A, which is a subcommittee dealing with the cables of ships and offshore units.
Yeah, that's the cable guys.
Yes, exactly. So I've just made this setup just to show that we have set up this in Norway in the same way as in IC. So we are just mirroring whatever happens in IC. So our Norwegian mother committee, NK18, mirrors the IC TC18, which also have a subcommittee. It's the subcommittee 18A. And then we have the similar setup. Yeah. So we have a lot of colleagues in the other committee. And also what the picture here doesn't show, that we also have another cable committee, which is NK20, mirroring TC20 in IC. where all the other cable standards are.
Yeah, on all the majority of cables onshore.
Yes,
they're much bigger, of course.
exactly. Yeah. So, but there are some of the standards that we refer to also come from TC20, of course.
Yeah,
so there's a sort of, this is just to say that there is a sort of a larger community of cable experts and standardization work, and but here today we are sort of focusing on ship and offshore units, and since we have spent most of the time on 606 offshore cable specifically.
And that is a responsibility of the lower left corner 18A, and K18A has responsible for the issue there.
So we meet sometimes a year, and of course recently we have been working on 606, so that of course has been the main agenda items. But of course we are looking at every documents that are coming from IC subcommittee 18A. If there is a draft there could be some document on an inquiry, so we go through that in our committee and work out the Norwegian comments and votings, of course, on those documents. But then, of course, we can also use, and we do use this group for discussing pretty much any, could be any technical topic that would be a problem for a member, or something going on in the business environment that is a technical problem. Yeah,
industry needs some new specification, like the DC cables. This is sort of driven from industry.
Yes.
So we kind of responded, what should we do? And we kind of come up with a standard, and okay.
And also to share experiences, you know, maybe some other committee member has some ideas on how to solve a problem or whatever. So this is why we discussed a little bit on how do we have an example? Can we to show you what we are discussing and what type of topics that could be. And then we came up with cable lugs, because that has been also one of the topics that we have discussed in the committee, and that we have had some meetings on and several discussions, and that's when we asked one of our members in the group, Hermod Iversen from Amo Kabel, to make a little bit a small presentation on this problem, to explain the problem and what can be done about it. So it's mainly about the cable lugs, the size of cable lugs and the size of cables, and the problems that can occur. So I think we can just play the presentation.
Yeah.
And see if we can comment on it afterwards.
Yeah. Hermod has a lot of experience to deliver cable lugs to the industry and different companies.
We will just bring it up on the screen here.
My name is Hermod Iversen. I'm a manager for Amo Kabel Norway AS. We are a cable distributor specializing in industrial and specialty cables. In addition to our products, we also provide expertise and technical support in this field. Our distribution center is located in Ålesund, and we currently have 16 dedicated employees delivering cables throughout Norway. Our main market is the maritime sector, including shipbuilding, offshore operation and aquaculture. In this post, I'd like to highlight a challenge that is often underestimated: how to correctly and safely connect a cable to a cable lug. So, challenges with cables and cable lugs. A conductor can be supplied in different designs, depending on the type of insulation it will be used for. The two most common ones are Class 2, stranded, that is relatively stiff, used for industrial setups and power distribution. Class 5, we say fine stranded, is a flexible multi-stranded conductor used where bending is necessary, such as panels and machinery. But we also have Class 1, so that's a single strand conductor typically used for fixed insulation where flexibility is not required. Class 6 is even more flexible than Class 5 and is ideal for dynamic application like robotics and transportation system. But the two most common one is Class 2 and Class 5. In the past, Class 2 was very dominating, but now the market is moving more and more for Class 5, 5-stranded cables. A cable log is a product designed to ensure safe energy transfer from the cable to the connection point. That means that there should be no lack in energy from the cable to the connection point. That means that we need to have a reliable connection between the cable and the lugs. But there's a challenge. There is many different types of lugs on the market today. What they all have in common is that they are constructed according to a standard. The most common one is KRT, the Deutsche Industrie Norm 46235, the French NFC 20130, and then we have the standard norm, trade norm, or Euro norm, what do you call it? It's called typical for from a company that have a big range of cable logs. You have known as Klauke log. All types give a good result with correct use of dies and crimping tools, and when the cable diameter matches, very important, the inner diameter of the cable log. So there's no bad logs, it's only bad connection, and as you as an installer need to be sure that you're using the correct cable lugs to the cable that you want to use in the market. A cable manufacturer like us does not supply a physical cross-section, but a conductor resistance according to IEC 60228, which means that a 95 square millimeters cable is not always 95. It can vary from 90 square millimeter, for example, or less upward, depending on the resistance and the construction of the conductor. A conductor of a high voltage cable has often strands that are compressed, which result in an even smaller diameter. Typical diameters for the Class 2, Class 5 is for 95 square, for example, it's 12.4. For a Class 5 conductor is 12.5 to 13.5. Also, Class 2 can be varying a bit from 12.4 up to 5 or 6, but that's in the range for the cable lugs. Compressed Class 2 conductor, 95, beware of where this, the diameter is 11 to 11.5. Can be a challenge for the cable lugs. The cable lugs and the cable manufacturer, they don't talk to each other, to be honest. The cable lug supplier provides dimension according to a specific standard, and they are fixed. But the cable manufacturer can deliver different dimension. The internal diameter for a 95 square cable can vary from 13.1 up to 15 millimeters, depending on the standard that are used. And remember, we have for compressed cables, threads, was it 11 millimeter up to 11.5. So that's a lot of millimeter between the conductor and the cable lug. Therefore, it's very important to follow the instruction from the cable lug supplier and to check the diameter of the conductor to ensure that that is a technical good connection. A general rule for this rule of thumb is that there should be around 0.5 up to 0.8 millimeter clearance on each side of the conductor within the cable lugs before the crimping. If it's too tight and you crimp it, you can also destroy some of the copper properties. You dry it out, and you can get some more resistance and heating up the cable lug. So it's not good to crimp too less, or it's not good to crimp too much. You see some pictures of cable lugs here. Typical, this is a French standard, this is the DIN standard, this is the Euro standard, and the other one up there is the KRF standard. Summary of this: always check the conductor diameter before crimping a cable lug. Always follow the supplier's recommendation for the pressing tool. Always use press and dies from the same supplier. Be especially careful when choosing cable lugs if using compressed conductors. If there are any doubt about the quality of the crimp within the current cable, a test should be performed with the supplier of the crimping equipment. That's a typical pull-out test. So see that it follows the demand of how many Newton meters you shall have in the cable lug when you take out the cables. You can also do some vibration test on the cable lugs to ensure that it can resist taking care of also the vibration. So this was a very short information about cable lugs. Thank you for your time.
Okay, then we have listened to Hermod and his presentation. I think it was very interesting. We got an explanation of the importance of using the correct cable lug diameter and to investigate the specification on the conductor.
Yeah, and don't follow the cross-section number blindly. Please don't take a 95 square exactly for 95. It has to be correct, let's say, clearing from the between the cable outer diameter, conductor outer diameter, and the cable lug inner diameter.
And we could, of course, have wished for this to be better standardized, but this, I think Hermod already explained a little bit that this has to do with the copper quality and the resistance, and you will have different dimensions on the conductors, and then
it's a combination of two products. You have a cable manufacturer, cable supplier, you have lug supplier, and these are not, I mean, it's not regulated how, except for aluminium cables we are very strict, but that's outside the scope of 606. But as with all combination of products, you need some kind of practice and professionalism to make it right, and also do the correct press using correct dice and press tool and everything.
And of course this was also an example then on what type of discussions we have in the committee. We are not only working on 606, we have other types of discussions, and this has been one of the discussions, and we have made some we have had some meetings to sort of raise awareness about this, and now we have done it today as well, I think, and hopefully listeners will be more aware of this challenge. Maybe it's not so easy to do something more about it within standards, but at least this is something the installers have to be aware of. Okay, Ivar, should we try to round and wrap up? We have one question that we would like to raise, even though we are 5 minutes above the hour. But let's take this question so we can answer this. I will read it out first. So we have a question here. It says that there are other types of offshore cables that are not listed in NEK 606, like, for example, Radox MFH SB offshore power cable. This cable is defined as NEK 606 compliant. What does that mean in regards to usage? So what do we have to say about that, Ivar?
Yeah, it's an interesting question. And it kind of, that's a general kind of topic we have in also in the classification societies in DNV. Like, shall we have a detailed specification that has its benefits, or shall we have a functional specification? That means make it the way you like it, but it has to work. So for flexible cable, that are cable that can be bent in a robotic arm or an elevator or such things, then we don't specify exactly how the cable should look like, because we don't have the competencies. It depends on the use and everything. So there we say, okay, make it the way you like, but it should be not be PVC, of course. But you have to test it for, like, say, 2 million cycles of bending. That's a functional specification. But in NEK 606, it is constructed by detailed specification, like many. Also, it's done in the shipboard standards and offshore standards for cables. So it means you can have these insulation materials, you can have this, it should be specific thickness, you should have the building up and the braid, or all the details are exactly, it's specified. You have options, but at least there is a way, a kind of rigid way how to make it and which options you have. So if you want a cable that is NEK 606 according, compliant with let's say P101 cable, it has to be with this insulation material, this conductor, this inner covering, halogen-free, the tinned copper wire braid, HFF or mud outer sheet, etc. If you make another cable, that can be very good, better maybe, but it's constructed with other materials, other dimensions. It can be a thin wall cable, which can be very good, but then it's not NEK 606 compliant by definition. It can be mud resistant if it passes the mud test, and in many cases we type approved cables and we say this is mud resistant according to NEK 606, but it's not the NEK 606 cable per definition. You mean, so it can have NEK 606 properties like mud, hydraulic oil resistant, and so. So the short answer is that it's only NEK 606 compliant to the specification card if it's within the specification. But if a yard or the one buying cable want to have another cable that is not NEK 606 but has some of property, they can specify that.
Because it goes back to what you mentioned at the beginning also, that yes, there are a lot of different cables for ships and offshore units.
Yeah.
But 606, the purpose is to narrow it down to a few cables that are applicable for some purpose.
Yeah.
And then, of course, we should probably add that it's the committee NK18A that discusses and develops this document. So, of course, anyone can join in the inquiry that we have. We have a public inquiry for this document. You can join in there and propose changes. And of course, it's also possible to join the committee and participate in the discussions there. So if there's something, a cable type that a new card, for example, that should be in there, it's possible to propose this.
Yeah.
And also, I should probably add that, of course, NEK, we are working on standardization and making the publications. We are not into sort of conformity assessment like DNV and other companies that doing that. So we provide a document, and then what manufacturers and the industry will use it for is not really up to NEK. It's up to governments, maybe conformity assessment companies, if they will require it or just recommend it or whatever. It's not sort of NEK's opinion. We just publish, we develop the document, and then industry use it afterwards. So of course the owners of infrastructure will be able to require, for example, they could say that for our project it should be 606 cables. Then it's a requirement. It's not NEK that made that requirement, but there is some stakeholder.
No, we offer a standard that the industry has used and adopted in many cases.
Okay, 10 minutes passed, so I think it's time to say goodbye. I just want to mention that our committees are, of course, open and transparent, so you can contact us if you want to become a member. And also remember to check out our newsletter. You can join that. And of course, on our web pages, you can have the complete overview of all our committees. I mentioned NK 20 and NK 18A, which are the cable committees. But there are a lot of different other committees. And you can join or just follow us on the newsletter. And also we have a list of what we have on webinars and conferences, etc. on our web pages. So I think that's it. Thanks a lot to Hermod Iversen, who made the very good presentation on cable lugs. Thank you, Ivar, for coming here today.
Thank you too.
And thank you for your time and listening today. Goodbye from Lilleaker at NEK.
Goodbye.